Hello, dear students. Today we will discuss example of load torque speed characteristics, which is the most important for the operation and synchronization of electrical drive system. Without information of load torque speed characteristics, engineers not synchronize the speed and torque demand by the mechanical load. So this is the most important topics for understanding the drive operations. So here we describe some examples of load torque speed characteristics available in nature. So first we will introduce in respect of need. So selection of particular type of motor for the driving in machine is the matching of speed torque characteristics of the driven unit and that of the motor. So which is the key points for understanding the problems of the drive system. So here we give a good example is a drum type hoist where the torque required varies with the loads on the hook but not with the speed of hoist. So quadratic torque is the most common load type. Typical applications are centrifugal pumps and fans. So the torque is quadrically and the power is cubically proportional to the speed. So these are the some examples. So the need of steady load torque speed characteristics. So first we classify the classification of load torques can be broadly classified in two categories. First is active load torque and second is passive load torque. So first, what is the meaning of active load torque? So load torques which have the potential to drive the motor under the equilibrium condition are called the active load torques. Such load torques usually retain their sign when the direction of the drive rotation is changed. And similarly, we define passive load torque. So load torques which always oppose the motion and change their sign on the reversal of motion are called passive load torques. Such torques are due to the friction, windage, cutting, etc. So now define the components of load torques. So as maybe define the components as per the natures of the load. So one is friction torques. The friction torque is equivalent value of various friction torques referred to the motor shaft. And second, windage torque. When the motor runs, the wind generates a torque opposing the motion. So this is known as the windage torque. Third, it is the most important torque, which is get the output. So mechanical load torque. So torque required to do useful mechanical work, that is called mechanical torque. It is referred as to the shaft. So nature of the torque depends on the type of loads. It may be a constant and independent of speed. Some function of speed, or maybe a time invariant or time variant, depend on the टाइम टाइम के साथ लोड का लोड की वैल्यू इंक्रीज और डिक्रीज सो कांस्टेंट और independent of this. Some may be function, square, proportional, inversely. So we will see in next slide. The nature of the torque may be changed with the change in the load mode of the operation. So here we describe the operation quadrant wise. Four quadrant operation: first quadrant, second quadrant, third quadrant, fourth. Whenever we introduce the drives, we already clear the operation will be a four quadrants: first quadrant, second, third, fourth. As you name: forward motoring operation, forward braking operation, reverse motoring operation, and reverse regenerative braking. So different type of loads shows the different speed torque characteristics. So now coming next slides, we have seen the different type of load exhibit different speed torque. So most of the industrial loads can be classified into the following four general categories. These are the most constant torque type. That is the means that load torque does not depend on the speed. Whatever speed may be increase or decrease, but does not change the value of torque. So constant torque type. Second, torque proportional to speed. This is generator type. Torque proportional to square of the speed. That is the means that torque is directly proportional to square of the speed. And fourth, torque is inversely proportional to speed. Constant power type. So as per the application of industrial load may be a four types. So one by one we describe here. First, constant torque. The speed torque characteristics of this type of load is given by T equal to K, where K is the constant. So working motor have a each mechanical nature of the work like shaping, cutting, grinding or shearing require a constant torque irrespective of the speed. Similarly, crane during the hoisting operation. Similarly, cranes during the hoisting and conveyors handling the constant weight of materials in a time also exhibit this type of characters. So this information is very important for the engineers when work in the industry. And second, torque proportional to the speed generated type load. Separately excited DC generator connected to a constant resistance load. Eddy current brakes and calendering machines have a speed torque characteristics given with the T equal to K omega, where K is the constant, T directly proportional to the speed. So these characteristics are given by this type of load. So in third, torque proportional to square of the speed, Fed type. So separately here, this is wrong. So here the speed is directly proportional to here. So this characteristics now come here. We change this perception. What this graph shows by the load. The load is directly proportional to square of the speed. So this types of load in available fan type of load. Fan type. So in fourth type, torque inversely proportional to the speed, constant power type of load. So in such type of load, torque is inversely proportional to speed or load wherever power is constant. So the most example, lathe machines, boring machines, milling machines, steel mill, color and electric traction are the most popular example of this type of. So this type of characteristics is given by the relation T inverse directly proportional to 1 upon omega. That is the means torque is inversely proportional. Whenever speed is reduced, then torque is increased. Whenever speed is increased, then torque is decreased. So most of the load require extra effort of the time of starting to overcome static friction. In a power application, it is known as a breakaway torque and load torque controlling. Here called a stiction. Because of stiction, the speed torque characteristics load is modified near to zero. So the speed is have a zero. So it is defined by zero speed. So these are the most popular example of loads. As we know, the nature of classification of load torque depends on a particular application. So a low speed hoist is an example of a load where the torque is constant and independent of the speed. So you can see this figure. So here, this is the most important example or traditional. This is the first quadrant operation, this is the second quadrant operation, and third quadrant and fourth. So as you can see here, so in this, when this first quadrant operation, the torque is positive, speed is positive. So this called is forward motoring. But in case of this is the braking, forward braking, and this is the reverse motoring, and this is the reverse reasoned braking. So these are the most important example of the load torque. And similarly, we can see some examples: fans, compressor, aeroplanes, centrifugal pumps, ship propellers, high-speed horse, traction are example case when load torque is function of a speed. So these are the four example where the load torque is directly proportional to the square of a speed. In case of high-speed hoisting, where here speed is 0 but load torque is high. So here the load torque, the speed is increased but some amount change in the value of load torque. So this is the high speed hoist application of speed torque characteristic. Similarly, we can talk about traction. This is the and the starting whenever your traction drive is speed is 0, then drive required a high starting torque. So here we use a series DC series motor because of DC series motor have a high starting torque. So for particular this application, if engineers have this knowledge, then we select the suitable motor for the driving a load. These are the example of constant power loads where the speed is torque, load torque is directly inversely is proportional to the speed. Whenever speed is high, then torque is low. So these are the basic example. Here also we example other figure and see high speed hoist के लिए and then traction load. And similarly we can explain other part of here whenever we talk traction load. So figure 2.7c shows the traction load torque function of only speed because we have assumed leveled ground. In actual practice, the train has no negotiate upward and downward slope. So consequently, a torque due to gravity which varies the position is also present. Furthermore, when the train take a run, the frictional force on wheel changes the substantially. Thus, traction is an example where the load torque also depend on position path followed. So these are the most application in the traction load. Thank you very much. I hope you understand this topic example of Lodox and what is the need, why we study of these topics, and what is the importance of electrical drives of this topic. Thank you very much.